What if the most valuable resource of the future isn't buried deep within the Earth but floating right above your head, on the moon? Imagine this. In just a few decades, your smartphone, your home's energy supply, maybe even the fuel that powers your car, could depend on something mined hundreds of thousands of miles away. Sounds impossible, right? But what if I told you the real gold rush of the 21st century won't be happening on Earth at all? In fact, it's already begun. Up there. Alright, before we dive deeper into the how and why of lunar mining, we've got to take a step back and look at the history of how we even got to this point. You've probably heard of the Apollo missions, those iconic moments in history when humans first set foot on the moon. But here's the thing, what started as a race for national pride in the 60s actually laid the groundwork for something far bigger, something we're just starting to realize now. So, let's rewind. 1969, Neil Armstrong says those famous words, "One small step for man, one giant leap for mankind." But back then, we weren't really thinking about mining the moon, right? It was all about exploration and proving we could get there. And then, crickets. After Apollo 17 in 1972, no one's been back. For decades, it seemed like the moon was just this cold, dead rock that we visited and then moved on from. Fast forward to the 21st century and something starts to shift. Private companies like SpaceX and Blue Origin began eyeing the moon not as a destination but as a resource. The conversations changed from "can we go there?" to "what can we do there?" NASA's Artemis program is even planning to set up a sustainable presence on the moon by the 2030s. So now we're not just talking about flags and footprints anymore. We're talking about building infrastructure, we're talking mining. But here's what's wild. None of this would have been possible without those early Apollo missions. They collected tons of data, soil samples, and learned about the moon's composition, which, by the way, is key to why mining there even makes sense in the first place. All that knowledge set us up for what's about to happen in the coming decades. Governments, corporations, they're all interested in it because they know what's at stake. And that brings us to the real question. Why the sudden interest in mining? Why now, after all these years? It's not like Earth's run out of resources, right? Well, maybe not yet, but we're getting close. And that brings us to 2070, when the moon will no longer be a distant dream, but an active mining hub that will shape economies, energy supplies, and maybe even your daily life. So now that we've got a bit of history under our belt, let's fast forward to the year 2070. Picture this. Earth's economy isn't just confined to the planet anymore. By 2070, lunar mining has become a major part of global trade. Sounds a bit futuristic, right? But think about it. How many things in your life today would have seemed like pure science fiction just 50 years ago? The internet, electric cars, AI. We've already lived through a technological revolution, and now the next one is taking us to the moon. But why does mining on the moon even make sense for the global economy? Well, it turns out the moon holds some pretty valuable stuff. Helium-3, for starters, could be a game changer. It's a rare isotope that could fuel nuclear fusion reactors, meaning it could help us generate clean, almost limitless energy. Imagine a world where the energy crisis is a thing of the past, where cities run on power mined from the moon. Kind of blows your mind, doesn't it? We're talking about something that could completely change the way Earth powers itself. And that's just one piece of the puzzle. The moon also has a ton of rare metals, stuff like platinum, yttrium, even gold. Things that are either super limited or expensive to mine on Earth. Now, why is that important? Well, with the rise of new technologies like electric vehicles, space exploration, and renewable energy, the demand for these metals is skyrocketing. And where do we get most of them right now? Earth's crust. But the thing is, Earth's resources aren't infinite. If we keep digging up rare metals here, we're going to hit a wall. The moon offers us a way to keep pushing forward without depleting our own planet's resources. Now, what's really interesting is how companies and governments are getting involved. You've got private corporations vying for lunar contracts, working alongside space agencies like NASA, ESA, and even newer players like China and India. It's not just a space race anymore, it's an economic race. Space is the next frontier for businesses, and mining is going to be a huge part of it. Think of it like the 1800s gold rush. But instead of heading west, we're heading up. But let's not forget, there are some pretty complex logistics involved. We're talking about setting up entire supply chains between Earth and the Moon. So, how do you move mined materials back to Earth? How do you keep costs down? There's going to be a lot of innovation in space transportation and infrastructure. Space elevators, reusable rockets, maybe even lunar manufacturing plants. It's all part of this future lunar economy. And we're going to see whole new industries spring up to support it. You're going to need engineers, miners, technicians, space pilots, you name it. Jobs that didn't even exist 50 years ago will become mainstream. And here's where it gets really fascinating. By 2070, we might not be thinking of the Moon as this far-off place anymore. It could become as integral to our economy as oil fields or shipping ports are today. The Moon might even have its own thriving economy, with businesses operating directly on its surface, and colonies of workers living there full-time. What's the value of the Moon by 2070? Well, if we play our cards right, it could be priceless. Alright, now let's talk tech. I know what you're thinking. How in the world do you even begin to mine the Moon? This isn't like digging into the Earth with bulldozers and drills. We're talking about an entirely different set of challenges. No atmosphere, extreme temperatures, lower gravity, and a surface that's pretty much covered in fine abrasive dust. So, the big question, how do you build a mining operation in a place like that? Well, the answer lies in technology. By 2070, we're going to see machines that make our current mining tech look like toys. Think about autonomous robots, advanced AI-driven systems that can operate without human oversight for weeks, maybe even months at a time. These aren't just the little rovers you see on Mars. These machines will be huge, durable, and incredibly smart. They'll be able to scan the lunar surface, detect valuable resources deep below, and then extract them, all without a human operator needing to step foot on the surface. But what about the drilling itself? Earth's drills rely on a lot of things that the Moon doesn't have, like air for cooling. So how do you drill through rock in a vacuum? Well, new technologies will probably use laser drilling or thermal processes, methods that don't rely on traditional mechanical friction. Lasers, right? It sounds like something out of Star Wars, but by 2070 this kind of tech will be the norm. These machines will vaporize rock, extract minerals, and sort everything autonomously. You don't need a giant human crew with pickaxes, just a few highly specialized robots. Another thing we need to consider is how we'll actually build these mining bases on the Moon. Remember, we can't just ship all the materials we need from Earth. It's way too expensive to send heavy construction materials up there. Instead, we'll have to use what's already on the Moon. This is where something called in situ resource utilization comes in. Basically, you use the Moon's own resources to build your structures. The regolith, the Moon's surface dust, can be used to make concrete, bricks, even glass. We're talking about 3D printing entire structures out of lunar soil. Imagine 3D printers the size of buildings, slowly constructing mining bases that can withstand micrometeorite impacts and radiation. And here's something you probably didn't expect: solar power. The Moon's lack of atmosphere means it gets blasted with sunlight, direct, uninterrupted solar energy. So, what do we do with that? We harness it. By 2070, solar panels on the Moon will be able to generate a ton of energy. Mining operations will likely be powered entirely by solar farms, using massive arrays of panels that can rotate to follow the sun across the lunar sky. And because the Moon has such a slow rotation, one side stays in sunlight for nearly 2 weeks at a time. That's an incredible amount of energy to work with. But of course, with all this tech comes a few challenges. One of the biggest is the Moon's dust. Lunar regolith is super fine and abrasive, and it gets into everything. It's like the glitter of space. It sticks to surfaces, clogs machinery, and even caused problems for the astronauts on the Apollo missions. That's something engineers are going to have to solve by 2070. They'll need to design equipment that can withstand constant exposure to this abrasive dust. Maybe we'll have self-cleaning machines or special coatings to protect equipment, who knows. But one thing's for sure, it's a problem that will need some creative solutions. Now there's also the issue of communication. Because the Moon is so far from Earth, there's a slight delay in communication signals. It's not a huge deal, only about 1.3 seconds. But it's enough that remote control from Earth becomes tricky. That's why AI is so important in this setup. Machines will need to make their own decisions in real time, adapting to changes in the environment or unexpected situations without waiting for human input. It's basically giving these robots a high level of autonomy. The future of lunar mining will depend on this blend of cutting-edge robotics, AI, and energy technology. Well, the first thing you have to consider is location. Where on the moon do you set up shop? Most likely we're going to see bases near the lunar poles, especially around the South Pole. Why? Because that's where the water ice is. Remember, water is absolutely critical, not just for drinking or making rocket fuel, but for running mining operations too. These polar regions also get more sunlight, which means more solar power for the base. The poles are basically the moon's prime real estate for both energy and resources. Now, once you've got your location, it's time to build. But here's the kicker. Bringing construction materials from Earth is a logistical nightmare. It's way too expensive to transport everything you need. So, we're going to have to get creative and use local materials. Enter lunar regolith, the dusty rocky stuff that covers the moon. As we touched on before, this regolith can be used to 3D print buildings. Imagine gigantic 3D printers that layer by layer build the walls of habitats, mining outposts, and storage facilities using nothing but the lunar soil. It's sustainable, efficient, and it means you're not relying on costly shipments from Earth. These structures will have to be tough though. The moon doesn't have an atmosphere, which means it's constantly being hit by micrometeorites, tiny space rocks that can cause serious damage. And then there's radiation. Without the protection of an atmosphere, cosmic rays and solar radiation hit the lunar surface full force. So how do we deal with that? One solution is to build underground. If we can burrow into the moon's surface, we can use the regolith itself as a shield. Some designs even suggest building bases inside lava tubes, natural tunnels formed by ancient volcanic activity on the moon. These tubes would offer natural protection from both radiation and micrometeorite impacts. But what about the people who will be living and working there? This isn't like setting up camp in Antarctica, it's far more extreme. By 2070, we might have small crews living on the moon for months at a time, so we'll need habitats that can support human life. These habitats will need to be pressurized, climate-controlled, and equipped with life support systems that recycle air, water, and waste. Think of them as mini ecosystems. Everything has to be self-sustaining. There's no running to the hardware store if something breaks down. So, redundancy and durability will be key. You'll probably see habitats designed like modular units, where each piece can be replaced or repaired with 3D printed parts from the base itself. And then there's the question of energy. How do you power an entire mining base on the moon? Solar power is going to be a big part of it, especially in those polar regions where you get near continuous sunlight for weeks at a time. But solar isn't foolproof. You've still got the 2-week lunar night to contend with. That's where energy storage comes in. We're going to need batteries, or maybe even nuclear power, to keep things running when the sun's not shining. Some concepts suggest building nuclear reactors right on the moon. Small, portable reactors that can provide a stable energy supply around the clock. Of course, there's also the logistical side of things. How do you keep these bases supplied with food, equipment, and other necessities? It's likely that in 2070, we'll have regular shipments from Earth. But over time, the goal is to make these bases as self-sufficient as possible. This means growing food on the moon, recycling water and oxygen, and manufacturing tools and replacement parts locally. The idea is that eventually, lunar bases won't need constant resupply. They'll be able to operate on their own for long stretches of time. So we've covered the bases, literally, but let's dive into one of the biggest reasons we're even thinking about mining the moon helium-3. You've probably heard this thrown around in conversations about space mining, but what exactly is helium-3, and why is it such a big deal? Well, helium-3 is an isotope that's incredibly rare on Earth but is surprisingly abundant on the moon. And here's the kicker, it could be the key to solving one of humanity's biggest challenges: clean, nearly limitless energy. Right now, most of our power on Earth comes from fossil fuels: coal, oil, natural gas. We know the problems with that: pollution, greenhouse gases, limited supplies. Then we've got nuclear power, which is cleaner but comes with its own set of risks, like radioactive waste and the threat of meltdowns. So, where does helium-3 come in? Well, it's a fuel that could be used in fusion reactors, not fission like we use in today's nuclear reactors, but fusion, the process that powers the sun. Imagine harnessing the same kind of energy that stars produce, but doing it safely here on Earth. Now you might be wondering, why don't we just use helium-3 from Earth? The thing is, it's almost non-existent here. Our atmosphere and magnetic field prevent most of the helium-3 from the sun from reaching the surface. But on the moon, there's no atmosphere to block it. And over billions of years, the solar wind has deposited significant amounts of helium-3 in the lunar soil. It's just sitting there, waiting to be mined. And the best part? Fusion using helium-3 produces almost no radioactive waste. That's right, no dangerous waste products, no risk of a nuclear disaster. It's as close to perfect energy as we're likely to get. So, how does it work? Fusion reactors would combine helium-3 with deuterium, a type of hydrogen, to create energy. The reaction releases a massive amount of energy in the form of charged particles, which can be turned directly into electricity without the need for giant turbines like in today's power plants. And because there's no radioactive waste, the reactors themselves would be safer, smaller, and easier to manage. Now, we're not quite there yet. Scientists are still working on getting fusion power to the point where it's viable. But by 2070, it's highly possible we'll have figured it out, and helium-3 will be a major part of that equation. Now you might be asking, how much helium-3 do we actually need to make this work? Well, just 25 tons of helium-3 could power the entire United States for a whole year. That's insane, right? We're talking about shipping a few tons of material from the moon to Earth to solve our energy problems for good. It almost sounds too good to be true. But this is what's driving the push for lunar mining. The countries and companies that figure out how to extract helium-3 and bring it back to Earth are going to be in a powerful position. It's basically the energy race of the future. And it's not just about Earth, either. Helium-3 could also power future space missions. Imagine using the fuel mined on the moon to power ships that travel deeper into space, to Mars, to the outer planets, maybe even beyond. By 2070, we could have entire fleets of spacecraft running on helium-3, making space exploration faster, cheaper, and more sustainable. We're not just talking about powering cities here, we're talking about powering a whole new era of human expansion into the cosmos. But of course, mining helium-3 isn't going to be easy. It's spread across the lunar surface mixed into the regolith, so it's not like we can just dig a hole and pull it out. We're going to need specialized mining equipment to scoop up the lunar soil, process it, and extract the helium-3. And because the concentration of helium-3 is so low, only about 20 parts per billion in the soil, it'll take a lot of effort to get even a small amount. But with the technology we've talked about, autonomous robots, solar-powered processing plants, it's totally within reach. There's another interesting angle here too. Once we start mining the moon for helium-3, we're going to see a whole new kind of geopolitical competition. Just like countries today compete over oil reserves, there's going to be a race for helium-3. The countries that establish the first lunar mining operations will have a huge advantage. Think about it. If you control the fuel source for the world's energy, you basically control the future. So, by 2070, we could see alliances, treaties, maybe even conflicts over who gets to mine the moon. Alright, so we've talked about helium-3 and why it's the moon's golden goose, but how do we actually extract it and everything else from the lunar surface? The answer? AI and automation. By 2070, human hands won't be doing much of the heavy lifting on the moon. In fact, it's unlikely there will be many humans on the lunar surface at all during mining operations. Instead, the future of lunar mining is going to be all about autonomous machines and artificial intelligence. Here's the thing. The moon isn't exactly a comfortable place to work. We're talking about extreme temperatures, a lack of atmosphere, no breathable air, and that relentless lunar dust that gets into everything. So sending humans there for long-term manual labor, not ideal. That's why automation is going to be the backbone of lunar mining. Imagine an army of robots, all equipped with sensors, lasers, and AI, digging into the lunar soil, sorting minerals, and processing helium-3, all without human intervention. Now you might be wondering, how smart are these machines going to be? Well, by 2070, AI will be so advanced that these systems will be able to learn and adapt on their own. They'll map the lunar surface, identify the richest deposits of helium-3 or rare metals, and optimize their mining routes in real time. You're not going to have someone on Earth controlling them with a joystick. These robots will be fully autonomous, making decisions on the fly based on the data they're collecting. It's like having a fleet of self-driving cars, but instead of taking you to work, they're digging up precious resources on the moon. But what about maintenance? You can't exactly call a repair technician when one of these machines breaks down on the moon. That's where AI and 3D printing come in. These mining bases will likely be equipped with their own on-site manufacturing capabilities. If a part breaks, the robots will diagnose the problem, print the replacement part right there on the moon, and make the repair, all without human intervention. It's the ultimate self-sustaining system. And with 3D printing, you're not just limited to simple parts. By 2070, we'll likely be able to print complex electronics, tools, and even whole new machines from raw lunar materials. Another huge advantage of using AI and robots is that they don't need food, water, or air. They can work 24/7, non-stop. No lunch breaks, no sleeping, no need for life support systems. They're perfectly suited to the harsh lunar environment, which means they'll be far more efficient than human workers could ever be. And because they're autonomous, they can operate continuously, even during the 2-week-long lunar night, when temperatures plunge to minus 280 degrees Fahrenheit. They'll be using stored energy, maybe from batteries or nuclear power, to keep things running. But let's not forget that even with all this advanced technology, we're still going to need humans, just not in the same way we do now. By 2070, human workers will be more like mission controllers or supervisors, monitoring the operations from Earth or from a lunar orbiting station. These AI systems will be sophisticated enough to handle day-to-day operations, but humans will still be there to troubleshoot complex problems, make high-level decisions, and ensure everything runs smoothly. We're talking about a shift in how we think of work itself. Instead of miners on the ground, you've got engineers and AI specialists managing fleets of robots from thousands of miles away. And here's where it gets really interesting. The data these machines collect, everything from the composition of the lunar soil to the behavior of the robots themselves, will be fed back into massive AI systems on Earth. These systems will continuously learn and improve, optimizing future missions and mining operations. Think about it like this. Every mistake a robot makes, every little hiccup in the system will make the entire operation smarter over time. It's an evolving system. And by 2070, AI could be so advanced that it's not just mining the moon, it's figuring out new, more efficient ways to do it that we humans haven't even thought of yet. And this isn't just limited to the moon. The same AI and automation technology we use for lunar mining could be applied to future missions to Mars, asteroids, and beyond. The lessons we learn from mining the moon, how to operate in extreme environments, how to make robots self-sufficient, how to use local materials to build infrastructure, are going to be invaluable as we expand into the rest of the solar system. By 2070, we might be using AI-driven mining machines not just on the moon, but on every major body in our solar system. Okay, so we've established that robots and AI are going to do the heavy lifting on the moon, but where does that leave us, the humans? I mean, mining operations can't be entirely hands-off, right? Even with the most advanced tech, we're still going to need people involved, especially for making strategic decisions, handling emergencies, and keeping everything on track. So, what's life going to be like for the humans who are part of this grand operation? What's it actually going to take for us to live and work on the moon in 2070? First off, let's start with where these people are going to be living. If you're imagining some kind of futuristic moon base straight out of a sci-fi movie, you're not far off. By 2070, we're looking at fully self-sustaining lunar habitats, probably near the moon's poles, where there's more access to sunlight and, more importantly, water ice. These habitats won't just be tents or temporary shelters, they'll be highly engineered, permanent structures. built from materials mined and processed on the moon itself, thanks to technologies like in-situ resource utilization and 3D printing. They'll be designed to protect against radiation, micrometeorites, and extreme temperature shifts. But here's the thing. Living on the moon is no walk in the park. The gravity is only about 1/6 of what we're used to on Earth. That sounds fun at first, right? Jumping higher, moving faster. But over time, low gravity takes a toll on the human body. Muscle atrophy, bone density loss, changes to your cardiovascular system, none of that is great if you're planning to be there for months at a time. So, what's the solution? We're likely going to need special exercise regimens, maybe even gravity suits that help simulate Earth-like conditions to keep people healthy. Space medicine will have evolved by then, and we'll have a better understanding of how to counteract these effects, but it's still a major challenge. Now, as far as day-to-day life goes, these lunar workers won't be slaving away with shovels and the regolith. They'll be mission controllers, overseeing the autonomous systems, managing the flow of resources, and troubleshooting any issues that arise. Picture mission control on Earth, but on the moon. You're surrounded by screens, data feeds, and communication systems, and your job is to make sure everything runs smoothly. But unlike Earth, you're not just a phone call away from help. There's a certain level of isolation that comes with living on the moon. Even with advanced communications, you're hundreds of thousands of miles from Earth. That distance changes how people live and work together. And this brings us to one of the most fascinating parts of lunar life, the psychology of isolation. How do you keep a small group of people mentally healthy when they're living in such an extreme, isolated environment? By 2070, we'll have learned a lot from experiences in places like Antarctica or on long-duration space missions, but the moon is a whole different ballgame. There's the constant darkness of the 2-week lunar night, the monotony of daily routines, and the knowledge that you're a long way from home. To combat this, we'll probably have virtual reality systems to help people feel connected to Earth, whether that's simulating nature, connecting with family, or just giving workers a mental escape. VR could even simulate the feeling of being in a lush green park or on a beach, something that's impossible to experience on the barren lunar surface. One of the key things we'll need is a strong sense of community. Teams working on the moon will have to be incredibly tight-knit. Living in close quarters, they'll need to rely on each other for emotional and psychological support. It's not just about getting the job done. It's about maintaining morale, managing stress, and dealing with the inevitable conflicts that arise when you're stuck in a confined space with the same group of people for months on end. Training for lunar missions won't just be about physical preparation, it'll include psychological training, learning how to communicate effectively, manage disagreements, and keep spirits up. But of course, there's also the excitement of being part of something groundbreaking. Imagine being one of the first humans to live and work on another celestial body. You're not just a miner, you're a pioneer, helping to establish humanity's first permanent foothold outside of Earth. That kind of sense of purpose can be incredibly motivating. By 2070, these lunar workers might feel like the early explorers of Earth, pushing the boundaries of what's possible. They'll know that they're part of something bigger, an operation that's not just about mining resources, but about creating a blueprint for how humans can live and thrive beyond our home planet. And let's not forget the personal experience of being on the moon. The view alone would be worth the journey. Imagine looking up at the sky and seeing Earth, this blue and white marble hanging in the blackness of space. It's not just a dot like the moon looks to us now, it's your home, and you're seeing it from an entirely different perspective. That's got to be a deeply emotional experience. It's one thing to see it in pictures, but to be there, to really feel the distance and isolation, it changes your perspective on everything. Maybe by 2070, lunar workers will have regular live streams of the Earthrise, or even send personal video messages back home, sharing that breathtaking view with the world. Alright, so we've explored what life and work on the moon will look like, but there's another layer to this whole lunar mining adventure that we need to unpack: the legal and ethical considerations. As we venture into this new frontier, it raises some really important questions. Who owns the moon? Can anyone just claim a piece of it? And what happens if something goes wrong? By 2070, These issues will be at the forefront of lunar exploration and mining. Let's start with ownership. Right now, the Outer Space Treaty of 1967 is the main framework governing space activities. It states that no country can claim sovereignty over celestial bodies, so theoretically, no one can say, "This part of the moon is mine." But we know that's going to be challenged as countries and private companies start investing in lunar mining. Imagine a scenario where several nations are racing to stake their claims on the moon's resources. How do we ensure that it's done fairly? By 2070, we'll likely need a new set of international laws that specifically address lunar resources, defining who can mine what and under what conditions. Then there's the question of environmental impact. We've all heard about the importance of protecting our planet's ecosystems, but what about the moon's environment? Mining operations, even if they're automated, could disrupt the lunar surface and create waste that could linger for years. What happens if we create dust clouds that obscure the precious solar panels we're relying on for power? Or worse, what if we damage sites of scientific interest like the Apollo landing sites? By 2070, we'll need to implement regulations that prioritize sustainable practices and minimize harm to the lunar environment. That could mean limiting the areas we mine or establishing no-go zones around important scientific sites. And then there's the ethical question of resource allocation. If a few powerful countries or corporations dominate lunar mining, what happens to the benefits? Do we end up with a new kind of space colonialism, where only the wealthy nations can reap the rewards of lunar resources? This could create significant tensions between nations, not to mention inequalities back on Earth. By 2070, we might see calls for a system where the benefits of lunar mining are shared globally, maybe even creating an international lunar resource fund that helps support sustainable development projects on Earth. It's a complex issue, and we're going to need to think critically about how we approach it. Let's not overlook the potential for conflict. If two nations or companies claim the same resource or area on the moon, what happens? Right now, we have a framework for resolving disputes on Earth. But in space, it's a bit murky. We could end up with a scenario reminiscent of the gold rush, claims staked, disputes arising and tensions building. By 2070, there will likely need to be clear protocols for resolving conflicts over lunar resources. Maybe we'll have an international lunar authority, akin to the International Maritime Organization, that mediates disputes and ensures fair practices. Speaking of governance, how will mining operations be regulated? Who enforces these laws? By 2070, there could be an entire bureaucratic system set up to oversee lunar mining, complete with inspectors, licenses, and permits. But let's face it, regulating operations on the moon from Earth is a logistical nightmare. Communication delays mean that it could take minutes to relay information back and forth, complicating enforcement and oversight. We'll need to develop new ways to monitor operations and ensure compliance, possibly using AI and remote sensing technology to keep an eye on mining activities. Then there's the question of the people involved in these operations. What rights will they have? If someone is working on the moon for a private company, what happens if they get injured? Are they covered by Earth's labor laws? It's a gray area. By 2070, we'll likely need to establish a framework that protects the rights of workers on the moon, ensuring they have access to proper medical care, fair wages, and safe working conditions. Imagine dealing with a workplace accident in a zero-gravity environment. Those regulations will need to be crystal clear. Lastly, let's consider the broader implications of lunar mining. How does this play into humanity's role in the universe? If we begin exploiting resources on the moon, it could change how we view space exploration as a whole. Will we become caretakers of these celestial bodies, or will we just treat them as new frontiers to plunder? By 2070, we might see a shift in perspective, pushing for more of a stewardship model, recognizing that we have a responsibility to not only our planet but also to the celestial bodies we explore. Now that we've navigated the legal and ethical waters of lunar mining, let's take a step back and look at the economic impact this entire endeavor could have, not just for the countries and companies involved, but for the global economy as a whole. By 2070, lunar mining could significantly reshape industries, create new markets, and drive technological advancements that ripple throughout society. First off, Let's talk about the potential value of the resources we could extract from the moon. We've already touched on helium-3, which could be a game-changer for energy, but that's just the tip of the iceberg. The moon is believed to have a treasure trove of rare earth elements and metals like platinum, which are critical for advanced technologies like batteries, electronics, and even renewable energy systems. Imagine a world where we can tap into these resources without the environmental and geopolitical complications tied to mining them on Earth. The economic implications of this could be enormous. In terms of job creation, we're not just talking about miners. This new lunar economy would need engineers, scientists, technicians, and support staff back on Earth. Think about it. Every lunar mission will require a massive support infrastructure involving design, research, logistics, and transportation. By 2070, entire industries could emerge around lunar mining operations, creating a new sector of jobs that didn't even exist a few decades ago. And let's not forget about the potential for private companies to get involved. With advances in space technology, we're likely to see a boom in entrepreneurial ventures focused on space mining, which could lead to increased competition and innovation. Now, let's consider the investments involved. The initial costs of setting up mining operations on the moon are going to be astronomical, pun intended. But once that infrastructure is in place, the returns could be massive. Governments and private companies might start pouring billions into lunar mining ventures, potentially leading to a new space race focused on economic domination, rather than just scientific exploration. We could see stock markets reacting to lunar developments just as they do to news about oil reserves or tech breakthroughs here on Earth. And speaking of investment, this could lead to the development of new technologies that benefit not just space mining, but various sectors back on Earth. The technology to mine and transport resources from the moon will require innovations in robotics, AI, and materials science. The breakthroughs that happen in these areas could lead to advancements we can't even predict yet. Just think about the internet. Many of its foundational technologies were developed during the space race. By 2070, we might be on the brink of another technological revolution driven by lunar exploration. Another key point is the potential for international collaboration. With the economic stakes so high, countries might see the value in working together rather than competing against each other. We could witness partnerships that pool resources, knowledge, and technology to make lunar mining a success for everyone involved. This kind of cooperation could lead to more peaceful relations between nations, as they focus on shared goals rather than territorial disputes. If everyone's got a stake in the moon's wealth, we might see a shift in how countries interact on a global stage. But there are challenges to consider as well. With the promise of wealth comes the risk of economic inequality. If only a few powerful nations or corporations control the lunar resources, we could see widening gaps between those who benefit from lunar mining and those who don't. It's crucial that as we develop these operations, we also think about creating fair and equitable systems for distributing the benefits. By 2070, discussions around this could lead to innovative economic models that prioritize inclusivity. And let's not forget about the potential impact on Earth's markets. If we suddenly have access to a massive amount of precious metals and rare earth elements, it could disrupt existing markets. Prices might drop, impacting mining industries worldwide. This could be a double-edged sword. While it might lead to more affordable technology on Earth, it could also result in job losses and economic downturns in traditional mining regions. We'll need to be prepared for these shifts and think about how to support communities that could be affected. Finally, the psychological and cultural impacts of lunar mining shouldn't be overlooked. If the moon becomes a source of wealth, it could change our perspective on space entirely. No longer just a barren wasteland, the moon could be seen as a vital economic resource, altering public perception and perhaps even inspiring a new generation to pursue careers in space exploration and science. We could see a cultural renaissance focused on the stars, fostering curiosity and innovation in ways we can only imagine. Alright, now that we've explored the economic landscape of lunar mining, let's shift our focus a bit and look to the future. What does all this mean for lunar colonization and humanity's presence beyond Earth? By 2070, mining operations on the moon could serve as the foundation for something much larger. establishing a permanent human presence and even colonization. Let's start with the basics. If we're mining the moon, that means we're going to need infrastructure. We're talking about habitats, energy sources, transportation systems, and communication networks. By 2070, we might see the first small lunar colonies, self-sustaining habitats where people live and work, growing food, conducting research, and yes, mining resources. These colonies could be designed to support both mining operations and scientific endeavors, acting as research hubs for studying the moon's geology, astronomy, and even the effects of low gravity on the human body. But it's not just about the moon. The technologies and methods we develop for lunar living will be essential for future missions to Mars and beyond. The lessons we learn from establishing a lunar colony will inform how we set up habitats on other planets. Just think about it. Everything from life support systems to agriculture techniques will have to be adapted for different environments. By 2070, the moon could serve as a testing ground for Mars colonization, allowing us to refine our approaches and ensure we're ready for the challenges that come with settling on another planet. Now, let's consider the social aspects of lunar colonization. As people start to live on the moon, we'll have to think about governance, community, and culture. Will there be a lunar government? How will laws be enforced? What kind of social structures will develop? By 2070, we could see the emergence of a unique lunar culture, influenced by the challenges and opportunities of life on the moon. Perhaps we'll have lunar art, music, and traditions that reflect the experiences of living in such an extraordinary environment. Education will also play a crucial role. Imagine a new generation of children born on the moon. What will their education look like? By 2070, there could be lunar schools that teach both Earth-based subjects and unique lunar studies, like how to farm in low gravity or how to design structures that can withstand micrometeorite impacts. This new educational model will not only prepare them for life on the moon, but also equip them with skills that could be crucial for future space exploration. As we think about this future, we also need to consider the environmental responsibilities that come with colonization. Just as we've talked about sustainable mining practices, we'll need to apply those principles to how we establish colonies. The moon is a delicate environment, and we must ensure we're not repeating the mistakes of our past on Earth. By 2070, we could see regulations in place to protect the lunar environment, with colonies designed to minimize waste and use renewable energy sources. This could set a precedent for how we approach colonization on other celestial bodies. Let's not overlook the potential for collaboration on a global scale. Establishing a lunar colony isn't just a job for one country or company, it's a collective effort. By 2070, we might see international agreements in place to share resources, technology, and knowledge, much like the collaborative projects we see on Earth today. This cooperation could lead to a unified approach to not just lunar colonization, but also the exploration of Mars and beyond. Now, looking even further ahead, what's the ultimate goal? Could lunar mining and colonization be the stepping stones to a multiplanetary existence? As we establish a presence on the moon and gain experience, the dream of Mars and beyond becomes more achievable. By 2070, we might be laying the groundwork for the first human missions to Mars, using the moon as a launch pad, literally and figuratively. The resources we gather from the moon could support these missions, making it feasible to send more people and supplies to our neighboring planet. And what about other celestial bodies? As our technology advances, we might not just be focused on the moon and Mars. The asteroids, Titan, Europa, there are countless destinations in our solar system that could hold potential for mining and colonization. The moon could serve as a base for launching missions to explore and possibly settle these places, turning the dream of becoming an interplanetary species into a reality. Finally, let's talk about the philosophical implications. What does it mean to be human as we expand our presence into the cosmos? By 2070, we might be confronting big questions about identity, community, and our place in the universe. As we venture beyond Earth, we'll have the opportunity to redefine what it means to be human in the context of a broader cosmic community. So, as we wrap up our discussion about the future of lunar colonization, we can't forget about the critical role that technology will play in all of this. By 2070, the success of lunar mining and the establishment of colonies will largely hinge on our technological advancements. Let's dive into some of the key technologies that will shape this new frontier. First up, let's talk about robotics and automation. We've already mentioned how robots will be crucial for mining operations, but they'll also be essential for building and maintaining lunar habitats. Imagine fleets of autonomous drones equipped with three-dimensional printers that can construct habitats using lunar regolith, turning the moon's surface into a living space without the need to transport materials from Earth. These robots could also perform routine maintenance, reducing the risk for human workers and ensuring that everything runs smoothly. Then there's artificial intelligence. AI will be our brain in this operation, managing everything from logistics to safety protocols. Picture AI systems that can analyze data from lunar mining activities in real time, optimizing operations and predicting potential issues before they arise. We could even have AI-assisted decision-making where smart algorithms help human workers assess risks and make informed choices. By 2070, the integration of AI into lunar operations could enhance efficiency and safety, allowing for a smoother running of mining and colonization efforts. Next, let's discuss transportation technologies. Moving resources on the moon is a whole different ballgame compared to Earth. We'll need advanced transport systems, possibly using magnetic levitation or electromagnetic propulsion for quick and efficient movement of materials across the lunar surface. Imagine a network of transport vehicles shuttling between mining sites and habitats powered by renewable energy sources like solar panels. By 2070, this kind of transport infrastructure could be essential for maintaining a thriving lunar colony. Energy is another crucial factor. Establishing a sustainable energy system will be vital for supporting both mining operations and human life on the moon. Solar energy will likely be the primary power source, but we might also see innovations in energy storage and transmission. Advanced battery technology, perhaps utilizing materials found on the moon itself, could store energy generated during the 2-week lunar day to use during the long nights. By 2070, we could have a reliable, renewable energy system that powers everything from habitats to mining equipment. Now let's touch on life support systems. As we establish permanent habitats, we'll need sophisticated systems to ensure that humans can live safely and comfortably. We're talking about recycling water, managing waste, and providing a stable supply of oxygen. Technologies like closed-loop life support systems could be key here, allowing us to create a self-sustaining environment where waste is minimized and resources are reused. By 2070, these systems will have to be both efficient and reliable, ensuring that lunar residents can focus on their work without worrying about basic survival. Communication technology will also be critical. With the distance between the moon and Earth, we'll need advanced communication systems to ensure seamless contact between lunar operations and mission control back home. By 2070, we might have developed robust satellite networks that facilitate real-time communication, ensuring that lunar miners can get support and guidance whenever necessary. These systems will also be crucial for sharing data and findings with the scientific community back on Earth. Let's not forget about agriculture. As we discussed earlier, growing food on the moon will be essential for supporting a human population. By 2070, we could see the use of advanced hydroponics and aeroponics systems that maximize growth efficiency in low gravity. Imagine vertical farms that not only provide food but also contribute to the habitat's life support systems by generating oxygen and recycling carbon dioxide. These agricultural innovations will play a key role in making lunar colonies more self-sufficient. And finally, we have to talk about space travel technology. The advancements we make for traveling to and from the moon will also influence our journeys to Mars and beyond. By 2070, we might have developed new propulsion systems that reduce travel time, making it easier to send people and supplies back and forth. We could see reusable spacecraft designed for lunar missions that can also be adapted for deeper space exploration, creating a versatile fleet ready for whatever challenge comes next. As we explore the future of lunar mining and colonization, it's essential to consider the cultural impact this new chapter in human history will have, not just on the people who live and work on the moon, but on society back on Earth as well. By 2070, we'll likely see significant shifts in our culture, art, and even our worldview as a result of our ventures into space. Let's start with the people living on the moon. As we establish permanent colonies, those who live there will develop their own unique culture. Just think about it. These lunar residents will be pioneers, facing challenges and experiences that people on Earth can't fully comprehend. Their daily lives will be shaped by the realities of living in a low-gravity environment, and this shared experience will foster a sense of community and identity that's distinct from Earth. We might see the emergence of lunar traditions, holidays celebrating significant milestones in lunar history, like the first successful mining operation, or the establishment of the first lunar school. Cultural expressions could evolve too, from music inspired by the vastness of space to visual arts that capture the stark beauty of the lunar landscape. These cultural elements will not only enrich the lives of lunar residents, but also intrigue and inspire people back on Earth. Now let's consider how these developments will affect those of us living on Earth. As we learn about life on the moon, we'll be exposed to new ideas, perspectives, and philosophies. By 2070, it's possible we'll see a greater emphasis on collaboration and unity as humanity faces the shared challenges of life beyond our home planet. The very act of living on the moon could foster a sense of global citizenship as people from different nations come together for a common purpose. Media will play a crucial role in shaping our perceptions of lunar life. Imagine documentaries and reality shows following lunar miners and colonists as they navigate their daily lives. By 2070, this content could captivate audiences, sparking interest in space exploration and inspiring future generations to pursue careers in STEM fields. We could even see virtual reality experiences that allow people on Earth to visit the moon and interact with lunar settlers, deepening our understanding of their challenges and triumphs. Art will also evolve in response to our lunar endeavors. Artists may draw inspiration from the stark, beautiful landscapes of the moon, creating pieces that reflect the solitude and majesty of the cosmos. We might even see a new genre of literature emerging, focusing on life in space and the philosophical implications of becoming a multi-planetary species. By 2070, literature, music, and visual arts could all be influenced by the shared experiences of living and working in space. Education will adapt as well. Schools on Earth may introduce new curricula focused on space exploration, lunar geology, and even the ethics of mining extraterrestrial resources. By 2070, students might have access to programs that allow them to learn about lunar life in real time, connecting them with their peers on the moon, and fostering a sense of global connection. Imagine a classroom where students can communicate with lunar settlers and learn directly from their experiences. Philosophically, the act of mining and colonizing the moon will challenge our understanding of humanity's place in the universe. By 2070, we may be wrestling with questions like, what does it mean to be human in the context of space exploration? Are we stewards of the moon, or are we just repeating the mistakes of our past on Earth? These questions will likely spur debates in academic circles and among the general public, prompting us to reevaluate our values and responsibilities as we expand our reach into the cosmos. Moreover, the environmental ethics surrounding lunar mining will become a significant cultural discussion. As we strive for sustainable practices, conversations about resource consumption, conservation, and environmental stewardship will be at the forefront. By 2070, the cultural narrative around space exploration could shift towards a more responsible and mindful approach, emphasizing our duty to protect celestial bodies just as we should for our own planet. In terms of technological culture, advancements in space technology could inspire new fields of study and innovation back on Earth. By 2070, the influence of lunar technology might permeate various industries, leading to breakthroughs in fields like energy, robotics, and material science. We could see the development of a space tech culture where the excitement of lunar mining fuels creativity and innovation in everyday life. Let's think about the interplanetary dialogue that might emerge from our lunar experiences. As we establish a presence on the moon and possibly beyond, we could begin to discuss our place in the broader universe. Are we alone? What are the implications of discovering life on other planets? By 2070, these conversations could become central to our cultural identity, influencing how we view ourselves as a species and our aspirations for the future. Let's address the idea of ownership. Who truly owns the moon? The 1967 Outer Space Treaty established that no one nation can claim sovereignty over celestial bodies, but with commercial interests in lunar resources growing, this issue is becoming more complex. By 2070, we might see corporations and countries vying for access to lunar resources, potentially leading to conflicts over rights and claims. It raises a fundamental question. If we extract resources from the moon, who benefits? How do we ensure that the wealth generated from lunar mining is distributed fairly, both among nations and within our global society? Next, we have to consider the environmental ethics of mining on the moon. Just as we've seen the consequences of resource extraction on Earth, we must tread carefully on the lunar surface. By 2070, we'll need to develop guidelines and regulations to minimize our environmental impact, ensuring we don't damage the moon's unique ecosystem. After all, while the moon might seem barren, it's a valuable scientific resource. What if future generations want to study its untouched features? The ethical imperative here is to balance our desire for resources with the responsibility to preserve what remains. Let's talk about the potential for exploitation. With the promise of wealth from lunar mining, there's a risk that corporate interests could prioritize profit over the well-being of workers and the environment. By 2070, we'll need to advocate for ethical labor practices, ensuring that anyone working in lunar mining has fair wages, safe working conditions, and a voice in their work environment. Just because we're operating in space doesn't mean we should abandon our commitment to human rights. The question of cultural preservation is another important aspect. As we establish colonies on the moon, we must consider the cultural heritage of humanity as a whole. By 2070, there could be a growing recognition of the need to protect sites of historical significance like where astronauts first landed. What measures can we put in place to safeguard these sites from potential destruction or commercialization? These considerations will be essential in maintaining a connection to our past as we forge a new future. And speaking of future generations, we should also consider their rights. By 2070, children born on the moon will have a completely different experience than those on Earth. As we expand into space, how do we ensure their rights are respected? Will they have a say in how lunar resources are managed? It's vital that we engage in conversations about governance and representation for these future lunar residents, ensuring their voices are heard in discussions about their home. Another ethical dimension is the impact on Earth. As we extract resources from the moon, how will it affect our economies and environments back home? There's potential for both positive and negative consequences. By 2070, we'll need to examine how lunar mining could influence global markets and resource availability on Earth. Are we just shifting our consumption patterns from one planet to another? And how do we ensure that lunar resources do not lead to further inequality here on Earth? We should also reflect on the philosophical implications of becoming a multi-planetary species. By 2070, as we venture further into the cosmos, we might grapple with the ethical implications of our actions. What responsibilities do we have to other celestial bodies? Are we merely conquerors, or can we be stewards of the environments we explore? These philosophical questions will shape our approach to mining and colonization, as we seek to balance progress with ethical considerations. Then, there's the potential for unintended consequences. As we embark on this journey of lunar mining and colonization, we must be vigilant about the risks involved. By 2070, we could face unforeseen challenges, whether it's technological failures, accidents, or ecological impacts. Developing a framework for ethical decision-making will be crucial, ensuring that we're prepared to address any issues that arise responsibly and thoughtfully. Finally, let's talk about international cooperation. Addressing these ethical challenges requires collaboration among nations, companies, and stakeholders. By 2070, we might need to establish new frameworks for international law that govern lunar activities, focusing on ethical practices and shared responsibilities. What if we could work together to create an equitable system for managing resources that benefits all of humanity? The ethics of lunar mining and colonization are complex and multifaceted. By 2070, these discussions will be essential in guiding our actions as we venture into space. We must ensure that we approach this new frontier with a sense of responsibility and an awareness of the impact our decisions will have on future generations, both on Earth and on the Moon.